Hello, we're back with the first video lecture, and I had this set up earlier in the week as a really long video, and YouTube didn't like it. So what I've decided to do is kind of split it up into two parts. I'll have a short video introduction where I'll talk about the three things that you read about in the text: projections, datums, and coordinate systems. And then instead of me going through the actual assignment with you on this one, I'm going to send you to this page, the digital coast. I was going to go through this in the video, but this is perfectly easy enough for you to go through and do this on your own in your own time. And you'll probably get more out of it if you go through this on your own instead of me just kind of reading it to you. This is a nice little course from the NOAA Coastal Services Centers. It's oriented towards coastal environments, the ocean, but it's got a lot of really good information on projections, datums, and coordinate systems. And here's the course objectives, or the little objectives for this little mini course. It takes about an hour to go through. And so here's the objectives. You're going to be able to define and understand datums, coordinate systems, and projections. This is the main thing I want you to be able to get out of this. We'll come back to this topic later in the semester. I'm not so concerned about, you don't have to really get into the datums, so if they get to talking about datums here and there and it starts going over your head, don't sweat it. If any of this goes over your head, don't sweat it. At this point in the semester, I just want you to get some basic definitions and some basic understandings. Later in the course, we're going to come back and revisit this. This topic on datums, coordinate systems, and projections, especially coordinate systems and projections, is vitally important to understanding and being able to use GIS. Now, you can work with ArcMap and without ever having to know. ArcMap does a lot of the work for you. However, there are times you're going to get in ArcMap, and if you get into an advanced level, when you go beyond this course, you're really going to need to understand these things to be able to advance. So this is why we're addressing it twice. First as an introduction, a simple introduction. The book goes into it a little bit more than I'm back to this, so don't panic. So first an introduction, later on we get into details. All right, so getting farther into this, identify accurate datums, coordinate systems for the Pacific region. It's a Pacific oriented exercise here. You're going to be able to compare projections, assign suitable projections for different applications, and recall techniques in ArcMap, blah, blah, blah. I want you to pay attention to in this particular exercise. If you want to go through the entire thing, it takes about an hour, but there's only a few parts that I really want you to focus on. So if you don't want to get into some of the heavy-duty details, don't worry about it. I'll show you the parts that I want you to go to. So what you're going to do is and it's going to ask you to register for the course. Now look here, you don't have to register if you don't want to. You don't have to. It says, no thanks, just begin training. Let's get that going. So this is going to come up. And this is what I was walking you through in my original video. And I realized, it was, you can see it's asking me to, it wants to know. So I was doing with this without the sound. I was going to do all the things that the lady was saying. It was just way too much for the video. So here's what I would like for you to go through. Right here, here's what I would like for you to go through. The little buttons here, we have one for introduction, ellipsoids and datums. I would like you to do that one. You may do U.S. Pacific Island groups. I don't care if you do or not at this point. We'll get into that later. Coordinate systems and projections. Projections in ArcGIS and demonstrations, that's up to you if you want to do that now. We'll get back to those later in the semester, but your assignment today is to go through this introduction, ellipsoids and datums, coordinate systems, and projections. That should help make sense of the things in the text. I thought I had my text in here. I was going to hold it up, but that should help visualize some of the things they're talking about in the text. All right, before you get into that, let me give you some definitions. What do we mean by datum? Let's start with datum. Datum is simply the shape of the Earth. Now, you should see my little globe here. It's up here in front of my face. The Earth is not really shaped like this globe. It's, for one thing, it doesn't have American something in the middle of it. But the Earth is not this nice round ball. It's actually kind of, if I squish this down, it's fatter in the middle than it is from top to bottom because of centrifugal force. The Earth is spinning and spinning and spinning, and it goes around and around. And that force pushes it out in the center along the equator. So it's a little bit wider. And also, it's kind of lumpy. It's more like a rock than it is a perfect sphere. So it's kind of like, see how I've got my hands all squished down? There's places where the Earth dips, and there's places where it rises. We've got mountains, neat shapes across the Earth. And that is called geodesy. The study of the shape of the Earth is geodesy. Now, datum, when we talk about datum, when we get it in, again, we're revisiting this halfway through the semester. We talk about datum, we are talking, and at different times and in different people, different sponsorships of different organizations, they sponsor groups to go out and actually measure the shape of the Earth. And you'll see datum, WGS 84. Don't worry about what WGS 84 stands for. That just means that there was a group of people that went out and measured the Earth, and they called that measurement WGS 84, based on what they came up with the bumps and the dents and the squiggles and the bumps and I already said bumps and the mountains and the valleys and the dips and all that. Later on, someone comes along with better measuring tools, technology for measuring the shape of the Earth, and maybe that takes place. So they have a datum, something, 1990. That's what they call their shape of the Earth. And so when we get farther into this, we'll have all sorts of different names for different datums. Now, what datum does is, if you're working in ArcMap, and this will make more sense later, it may make your drawing, your map drawing, or your lines and your points where things should be, may make them off just a few meters to a few hundred meters. Let's move on to projection. Let's move on to projection. And again, this exercise, this NOAA exercise, will give you more information about all of these things. Okay, projection. I have a clear globe here, and you can see the continents and countries around the globe, right? Imagine if I took a light bulb and put this in the middle of the globe. If I put a light bulb in the middle of the globe, I wish I could figure out how to do that. And drop that down, and it's shining out. It's shining out, and what's it going to do? If you're in a dark room, it's going to shine out. It's going to project. It's going to project these continents. And anything that's not clear, it's going to project that on the wall back behind me, right? And so a projection is actually a mathematical prediction of what that, how that would appear on the wall. So imagine if I've got my clear globe. Put my little light bulb in there, and imagine if I have this sheet of paper, and it's bigger, and let's say it's a lot bigger, and I wrap the sheet of paper around the globe. Light bulb in it. It's kind of awkward holding it that way. Imagine that. Imagine if I'm able to take a magic marker on my piece of paper wrapped around my globe, and where I see the outline of, let's say, South America here, on my wrapped piece of paper. Imagine if I've got a magic marker and I can draw that if I can draw that on here. And I could probably do that. Um, if that's the case, and I may try to figure out a way to be able to show this to you. If that's the case, that I could do that, South America is going to, my drawing of South America here is going to be most accurate wherever this piece actually touches the globe, right? So wherever this thing is touching the globe, that my drawing is going to be most accurate. Beyond that, so I'm going to try to do this. I tried this earlier, it was quite awkward, and I'm just going to try this again. So here's the equator. I don't know if you can see it on there. There's my equator. And if I drew South America on here, imagine that it's going to be more accurate here at the equator. And up here and down here, where it's not touching the globe, it will be projected as it would be on the wall if I had my light bulb in here. Right? So that's what is meant by projection. It would be as if we took a piece of paper, put it on the globe, shined a light on it, and then drew the outline where it was projected on the piece of paper. Now, sometimes we put the piece of paper flat on the globe. Sometimes we wrap it around. Sometimes we make a cone out of it. Now, this is all done mathematically. There are mathematicians and cartographers and geographers and the like that have figured out if you did this, what it would look like. They use math to figure that out. Guess what? We don't have to. Awesome. We've got the software to do it for us. So if I make this into a cone and put it on the globe, wherever my cone touches the globe, it will be the most accurate on here. And this is as much as you need to know at this point. Again, we're coming back and looking into the nitty-gritty details and all the names and all the specifics of the different kinds of projections. But right now, just want you to know the definitions. Datum, shape of the earth. The datum is the measured shape of the earth. A projection is the shape. It's the predicted shape, the predicted outline, the predicted map that would be drawn if you had the light in the center of the earth and glowing out and projected on a screen or a piece of paper or whatever. That's why we call it projected, because it takes that shape and projects it out. A coordinate system is like what you had in high school math class. Now, I don't know if you can see this. I'm going to put it up really closely. You see that? It's gridded paper. If you didn't see it, I'll have a better example for you. This is a coordinate system. Coordinate system is when we take the Earth and we slice it up. We project it. Sometimes we project it, sometimes we don't. Say we project it, we put it on a piece of gridded paper, and we draw a map. So, I'm going to draw a map. A very bad map of Texas. Here's my very bad map of Texas. And believe it or not, this is how I teach in a classroom. I just do this on a chalkboard instead of a piece of paper. So, because I have this on gridded squares, hopefully you can see this, I can locate this. I can give that a coordinate. It's so many squares away from here, so many squares up from there. That's what is meant by a coordinate system. Coordinate system is simply something similar to what you've dealt with in your high school algebra class. X and Y. X and Y. So X across, Y up. So, when you get to working in the arc map, you won't be able to see this. Here's your Y-axis, here's your X-axis, but that's what you have. So many, I've got one, the tip of out here in El Paso is about, on the X-axis, because I didn't draw this quite well, is 1, 2, 3, 3.5. X is 3.5. And Y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and a half. So 3.5, X, Y, 15.5, that's your coordinates. That's what a coordinate system is. It is being able to put an X and Y system onto your map so that you can locate things. I'm in Austin, Texas right now. Austin, Texas would have an XY coordinate. So there's your coordinate system. It's being able to assign a location to where you are on the map. Now there's two different types of coordinate systems. There's geographic, and there is the Cartesian coordinate. The geographic coordinate system is we call it the round Earth system because it's based on angles, angular measurement. Go back to the center of the Earth here with our little light bulb in it. At the center of the Earth, where our light bulb is where we start. And you measure angles out from the center of the Earth, either around like this, from the prime meridian. The prime meridian is right here, goes through England. And so you count the angular measurement away from that prime meridian in these directions. That's your longitude. Latitude, you count the angle away from the equator, up or down. So, which one is your x-axis? Latitude or longitude? Latitude goes up, longitude goes around. Let you think about that for a bit. You might have read that. If you've read your text already, then you might know the answer already. So latitude goes up or down. So latitude is your y-axis. It goes along your y-axis. It goes up the y-axis or down the y-axis. So that means longitude is your x. And sometimes I have to think of that myself because latitude, zero, I kind of misspoke. I accidentally said this. But latitude, the equator is the x-axis. Prime meridian is your y-axis. So latitude, even though it's your x-axis, is actually your y-coordinate. X-axis, longitude. Okay, so that gives you the basics of all three. I'd like you to go through this understanding datums, coordinate systems, and map projections to help solidify and give you some visualization of what it's all about. And then please post your questions to either, you can send it an email if you don't want to post it publicly. I'm fine with that. I know some people get a little, oh, what if it's a bad question? What if it's a dumb question? It's not a dumb question. I like for you to share that publicly. But if not, send it as an email. If it's a quick question that's a yes or no answer or whatever like that, send it to me in a text. Anyway, enjoy your weekend. Have fun. And enjoy starting the learning process on projections, datums, and coordinate systems. Again, we're not getting into the details, so the book is we'll come back to this chapter in the book and we'll get into the nitty-gritty where you saw some things in the text about the UTM coordinate system. We're going to get into that in much more detail later. So, again, what I want you to understand, definition, datum, coordinate system, and map projection, and understand what they are. You don't need to know the details of each different type at this point. Thanks, and we'll see you later.